Let us see some applications of the intermediate value theorem. For instance, we can apply it to showing that this equation here, x to the power 3 minus 3x plus 1 equals 0, has a solution. So how do we do that? If we notice here, solving this equation is the same as saying that the function f of x equals x to the power 3 minus 3x is equal to -1 for some number. So what we are going to do, if we want to apply the intermediate value theorem, remember, in the intermediate value theorem, we have 2 points, A and B, and then we need to check that the function at f of A and f of B, they are on both sides of a certain quantity, which was the number capital N, which in this case is going to be -1. Okay, so let me summarize that. We need two numbers, A and B, such that f of B is less or equal than -1 and f of A is bigger or equal than -1. And this we find by inspection. Okay, so for example, a bit of trial and error will do it. So we can take, always start with the easy ones. So we can take A equals 0 and see that here we have f of 0 is going to be 0 minus 0, so 0. And then we can take B, 0 is okay, will work for A because it's bigger than -1. And here for B, we can try, well, let's say 1. As I said, let's try first the easy ones. So f of 1 is 1 minus 3, which is -2, and we were lucky. So we have f of B that is -2. Okay, so we have -2 less than -1 less than 0. And here we have our f of B. 0 is our f of A. And this is the number n that we had in the statement of the theorem. Okay. So for our f of A, we have something like this. Okay. There we go. And here is our f of B. And we have our n equal -1 here. And the theorem says that if the function is continuous, well, this may not be how the function actually looks, but if the function is continuous, it will cross the line n equal -1 at some value c. Okay. So, but remember, the theorem had a hypothesis. Okay, so something we always need to check, that f is continuous in AB, in this case, 0, 1. Okay, the closed interval. This is true because f of x is a polynomial. Okay, that didn't work. There we go. Now, once we know that the hypotheses are satisfied, then the intermediate value theorem implies that there exists some number c that is strictly between 0 and 1, such that f of c equals -1. Okay, that means that c to the power 3 minus 3c equals -1. That means that c is a root of the original equation of degree 3 cubic equation. Okay, so we know there is a root in the interval 0, 1. Okay, but you may wonder, can you give me the value? So what we can do is approximate that value to as good as an approximation as we want. Okay, how do we do that? So we can narrow down the interval to get a better approximation. That's what I was saying. And how do we do that? Remember the picture we have here. Let me copy paste. What we are going to do is to test at x equals 1/2. Okay, see if it's positive or negative. So at 1/2 we have 1/8 minus 3 divided by 2 because it was minus 3x. And this is -11 over 8, which is less than 1 and less than -1. Okay, so what does this mean? This means that our 1/2 is going to be here. Okay, this is 0, this is 1, this is 1/2. And the value c is going to be on the left. Okay, because f of 1/2 is negative. Is, sorry, less than -1. Now, you may be wondering, how do I know? So to check if -11 divided by 8 is less than -1, you just notice that -11, move the 8 to the other side, is less than -8. Okay, just a side comment. But here, for what we are concerned, once I know that f of 1/2 is less than -1, and it is still true that f of 0 was bigger, okay, then the intermediate value theorem, I can apply it again. It says that there is a solution in 0, 1/2. So we have improved from knowing that the solution was in 0, 1/2, 0, 1, sorry, to 0, 1/2. And we can keep splitting the interval. Okay, now we have here, actually, this is our a equals 0. Then we have here b equal 1. Okay, and here this is f of 0, and this is f of 1, and we have split this interval. Okay, and we can split it again and see what happens. Okay, here we found that this was negative. So if this was n equal -1 here, okay, there was some point where the function would cross. Now what we need to understand is if f of f at 1/4, is it bigger than -1? Is it smaller? Okay, because once we know that, we will know by the theorem that the solution is in 0, 1/4 or in 1/4, 1/2. This symbol here that is like a curve E means belong. C belongs to 0, 1/4 or C belongs to 1/4, 1/2. One of the two. So I leave that for you to check, which is which. And if you want to keep splitting the interval again and again, you will always have that f at that new value is either larger than -1 or smaller. And you keep going, and the approximation for your number C will become better and better. And if you do this, I don't know, 20 times, you will get the approximation to the solution with several correct decimal digits. Okay. For this, you of course would like to use a computer. They are much faster at this. But this is basically the way computers, calculators are able to give you an approximation of the solution to any equation. They don't use formulas, okay? They approximate in ways similar to this I just explained.